Well, greetings, Mr. Colazar's class. Our last section for our naming and writing of compounds is going to be on organic compounds. And so as we're going, what we're going to be looking at today are going to be our organic compounds. Kind of introduces us to the term hydrocarbons. And what those elements are going to be, we'll find out in just a second. But they're going to contain carbon. Our exceptions, carboxides, carbides, carbonates, are all inorganic molecules, not organic, so we're not going to have them in this section. And our other part to the studying of our organic compounds is something we'll talk about next semester. It's carbon bonded to either hydrogen or another nonmetal. And carbon, beauty of it is it can form 4 covalent bonds. So one carbon molecule can bond to 4 other molecules. Carbon, building block of our life. Also, it can bond with basically another carbon, and it can bond and continue to make, so almost nearly unlimited possibilities of compounds can be produced, but we're going to stick with just the basic ones. So in our notes, organic compounds are formed with carbon and hydrogen. Sometimes they're known as hydrocarbons. Now we're going to use what's known as our organic prefix system. And in that organic prefix system, we're looking at the number of carbons. So if we have a 1 carbon, would be meth, 2 carbons eth, 3 carbons prop, 4 bute, 5 pent, hex, hept, oct, non, and dec are going to be our 10 carbons, up to 10 carbon chains. So the prefix system is a little bit different. Don't worry, this one is also in your gold packet. You just need to know you're going to use this one anytime we're dealing with carbon. So if it's a carbon chain, it's how many carbons are in that chain using that chart. So just a little information. All of our hydrocarbons for now are going to end in the word ANE. So if you see ANE, that will tell us that we're using or going to be looking at carbon and hydrogen. If it ends in ANE, it's going to be a hydrocarbon, or ending with organic, ending in hydrocarbon, ends in ANE. So CH4, our most basic of our hydrocarbons, could structurally look like this, bonded to 1 carbon bonded to 4 hydrogens. There's our 3-dimensional model of it, and it's going to be known as methane. So methane, our first carbon, 1 carbon, ANE tells us it's a hydrocarbon, meaning it's bonded to those 4 hydrogens. Now please write this part down just somewhere off to the side in your notes. To find out how many hydrogens we have, you know the number of carbons from the name. So as we're going, how many carbons between 1 and 10 that we'll have in our carbon chain. And then to find out how many hydrogens you have, the number of carbons you have, you take that number, double it, and add 2. So whatever number you have, we're going to see on the next couple slides, you double and add 2 to find the number of hydrogens. So this is going to be used to find out the number of hydrogens that you have. So methane, ethane, propane, butane, any of these number of hydrogens, carbon, what we're going to do is you just take it times 2 and then add 2. So 2 times 2 is 4 plus 2 is 6. That's where that number comes from. 3 times 2 plus 2 gets us to 8. And that's where we get the number of hydrogens from. Structurally, to show it out, we're not going to worry about the condensed formulas. Structural formula, as we're going for each of these, shows our carbon bonded to 4 different atoms. If we have 2 carbons, for like ethane, carbon bonded to a carbon, and then each of these represents a hydrogen. But we're going to allow just the line to be drawn. We assume the hydrogens are at each spot if we don't draw a line in. So as we're going, we're focused just in on the length of the carbon chain. So as they get bigger up to our 10, C5, pentane, hexane, heptane, octane, nonane, and decane. So if we were to look at any of these, if we have 10 carbons, 10 times 2 plus 2 gets us to our 22 hydrogens. So as we're going, they all end in ANE, which you can see. And again, that pattern, number of carbons times 2 plus 2 gets us how many hydrogens we have. So to practice this out, if you were given a 1, 2, 3 carbon chain, we would look at the beginning. Prop would be our prefix, adding ane to make it our organic compound propane. Since it's 3 carbons, 3 times 2 plus 2 would give us a 3 carbon, 8 hydrogen, or you could count them out, 1, 2, 3, 5, 6, 7, 8, would give us our formula for propane. So please, on your notes, I'd like you to write down the formula and then also show me the picture of it. Our second one that we have here, we have a 1, 2, 3, 4, 5, 6, 7, 8 carbons connected in a row. If we have 8 carbons connected in a row, oct for the 8, ane, because it's a hydrocarbon, octane, 8 carbons, times 2 plus 2, C8, H18. Please write both of these down, the formula name and the actual name, or the formula and the name. Just the opposite way, if we were going and given the name first, say like heptane. Hept is 7, ANE tells us it's a carbon and hydrogen. So we need hept, our 7 carbons, 1, 2, 3, 4, 5, 6, 7. And to draw it out, we want a carbon, each carbon bonded to 4 different elements, hydrogens bonded, hydrogen bonded. In the end, heptane, C7, H16. 7 times 2 plus 2. So, decane, our largest of our hydrocarbons that we're going to deal with. Decane, 10 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon chain. Our formula for that, 10 times 2 plus 2, would give us a formula of C10H22. Butane, commonly found for lighter fluid. Butane, as we're going 1, 2, 3, 4 carbons for our 4 carbon chain from butane. All of them bonded to hydrogens, ANE. So our structural formula, C4H10. Double and add 2 to get to our structural formula there. Besides that, hydrocarbons all end in ANE and use our organic prefixes found in your gold packet. We'll let you start working on those.